Okay, picture this scene. It's August 10th, 1628. It's about 4 o'clock in the afternoon. The sun is shining brightly right on Stockholm Harbor, and thousands of people are gathered around, literally cheering at the top of their lungs. And they are all looking at the exact same thing, the Vasa. This ship is the absolute pride of the Swedish Empire. It's a massive, terrifying warship custom-built to utterly dominate the Baltic Sea. I mean, we're talking about a multi-million-dollar flagship here. And right now, it is less than a mile from the dock on its maiden voyage. The energy in the air is just electric. And then the unthinkable happens. A light gust of wind hits the sails. Now, actually, let me be totally clear here. This isn't a hurricane. It's not some sudden, violent freak storm. It is literally just a regular breeze that a normal, seasoned sailor wouldn't even flinch at. But the results? Absolutely catastrophic. The Vasa leans. Then it leans a little further. And then, well, it just doesn't stop leaning. Water starts violently punching through the open lower gun ports. And in less than 5 minutes, this marvel of modern warfare is sitting right in the mud at the bottom of the harbor. 30 people are dead, and it happens right in front of the very palace that commissioned it. No way, right? Section 1. The impossible sinking. A preventable math error. So what does this all mean? Well, this magnificent ship wasn't destroyed by some hidden enemy fleet. It wasn't ripped apart by a rogue wave or even terrible luck. It sank because of arithmetic. Yep, a single, completely human, entirely preventable math error written down months before the ship ever even touched the water. This explainer isn't just about a shipwreck, really. It's an autopsy of history's most embarrassing engineering failure. To understand how a machine this massive fails so instantly, you have to look at one absolutely fundamental concept: the center of gravity. Think about it. Every single ship on the ocean is basically just a giant balancing act. You desperately want the weight low down near the water. That's where the ballast comes in. We're talking hundreds of tons of stone packed tightly right into the bottom of the hull. That ballast is essentially the ship's way of whispering no to gravity whenever the wind tries to push it over. It's the anchor keeping the whole shebang upright. But with the Vasa, that center of gravity was pushed way, way too high. See, back then, Dutch shipwrights didn't really use formal math or blueprints. The actual mathematics of naval stability literally had not been invented yet. So they built ships based on experience. If an intended design worked before, you just scaled it up, which works perfectly fine, until King Gustavus Adolphus steps in and alters the deal midway. Sweden was at war, and the king demanded more firepower. He wanted these super heavy 24-pounder cannons, and he demanded a second full deck of guns stacked right on top of the first one. Every single heavy cannon they added to that upper deck raised the center of gravity higher and higher into the air. They essentially took a standard canoe hull and demanded a skyscraper be built on top of it. It turned the ship into an inverted pendulum, basically just begging to tip over. Section 2. Anatomy of a flaw. Compounding construction chaos. Okay, so the story of the Vasa gets remarkably worse midway through construction. The original master shipwright falls ill and dies, which is a massive, dramatic turning point. His poor assistant is suddenly forced to take over. He inherits a half-built ship, a dead boss, and a micromanaging, war-hungry king breathing right down his neck. And this leads to a detail that sounds like an absurd comedy sketch, but I promise you, it is 100% true historical irony. The carpenters building the left and right sides of the ship, they were using two completely different measuring systems. Swedish workers were using Swedish feet on one side, while Dutch workers were using Amsterdam feet on the other side. The difference between those two rulers is just 16 millimeters. Now, you might be thinking, 16 millimeters? That doesn't sound like a big deal when you're just chopping giant tree trunks in a shipyard, but let me tell you, it is an absolute nightmare when you're trying to build a perfectly symmetrical hull from opposite sides. Because of that tiny 16 millimeter discrepancy, the hull was completely asymmetrical. The ship was literally heavier and shaped completely differently on the port side than it was on the starboard side. Section 3, a comedy of errors, the ignored warnings. So, let's recap. We have a ship that is lopsided, overloaded, incredibly top-heavy, and built with mixed rulers. It begs the obvious question, right? How did absolutely nobody notice this disaster waiting to happen before they actually pushed it into the ocean? Well, they kind of did know. In the days right before the launch, they ran a crude, honestly terrifying dockside stability test. Step 1, 30 heavy sailors assembled on the upper deck. Step 2, they had them run back and forth from one side to the other just to see how the ship handled shifting weight. Step 3, pure panic.
The ship rocked so violently after just 3 passes that they had to abort the test immediately. They literally stopped because they were terrified the ship was going to capsize right there at the dock.
I mean, that wasn't exactly a subtle hint. That was the ship literally screaming for help, but a chain of silence took hold. The admiral, who oversaw the test, kept quiet. The captain, fully knowing the danger, sailed anyway. And absolutely nobody told the king. Fear of the chain of command, combined with the sheer unstoppable momentum of a royal project, completely overrode common sense. Leadership simply ignored the physics, and the ship sank. Section 4. The Intact Crime Scene. A 1961 time capsule.
The crazy thing is, the story of the Vasa doesn't actually end in the mud back in 1628. Fast forward 333 years. The Baltic Sea is incredibly cold, extremely dark, and almost entirely free of the wood-boring worms that normally devour old wooden shipwrecks. Because of these incredibly unique conditions, the Vasa just sat down there acting as a perfect, preserved time capsule. When they finally raised the ship in 1961, modern archaeologists were stunned. Investigators didn't just get shattered, rotting wood fragments to look at, they got the entire intact crime scene. They could closely examine the preserved tool marks. They could physically measure the uneven, lopsided hull. They were able to use modern forensic science to piece together and essentially reconstruct every single bad decision that led to that fatal August afternoon.
Section 5. The Ultimate Systems Failure. This incredible level of preservation is exactly why the Vasa is heavily taught today. If you go to modern engineering schools, design courses, or even software development seminars, you are going to hear about this ship. It serves as the ultimate case study of catastrophic systems failure. As you'll see, the Vasa proves that grand disasters rarely ever stem from one evil saboteur or a single massive explosion. They happen through a chain of blame. Disasters occur when a chain of people simply follow their orders and assume, hey, someone else further up the ladder probably checked the numbers. After the sinking, the shipwrights blamed the design. The admiral blamed the king. The captain blamed the wind. Everyone followed their specific orders, yet the system as a whole completely failed. And here is the uncomfortable truth. This isn't just some ancient history problem. This historical tragedy connects directly to our lives today. The Vasa in 1628 represents the exact same failure mode we see right now in glitchy software rollouts, in failing municipal infrastructure, and in chaotic corporate project management. It shows exactly what happens when schedule pressure and executive demands override fundamental technical reality. It really makes you look at our modern world completely differently, doesn't it? All those dense, seemingly boring building codes and really specific technical laws we have to follow today, they aren't just annoying bureaucracy. They are memorials. Every safety rule is written in blood. Someone, somewhere in history, found the absolute limit the hard way, so that the rest of us wouldn't have to. So I'll leave you with this. What modern systems do you trust every single day without even thinking about it? Whether it's the elevator in your building, the bridge you drive across, or the software flying your airplane, our world isn't held together by flawless genius. It is held together by the hard-earned rules we wrote after things fell apart. Think about that the next time you encounter a frustrating safety regulation. If you want to keep exploring the fascinating wreckage of history and understand how our world really works, we're going to keep digging into these incredible explainers to find out exactly where things went wrong. Make sure to subscribe because the next one might be a lot closer to your own life than you think.